Hi, my name is Chelsea Clifford. I'm a postdoc at Iowa State University. I'm recording this presentation for the Iowa Water Conference in April 2021 because I don't have a designated time slot. And I figured this way people can listen to me present this poster whenever, and maybe some people outside of the conference could view this as well if interested. If you want to reach me with questions, comments, to meet, anything like that, I'll put my contact information in the description of this video and within the Iowa Water Conference. My co-authors on this poster are Carl Peterson, Emily Waring, and Matt Helmers, so you can ask them questions as well. This poster is about changes in recent decades in corn yield and nitrate exports in Iowa and perhaps applies to the Midwest and some other places more broadly as well. In recent decades, corn yields have increased in the state of Iowa fairly consistently. This change is often attributed to a concurrent increase in rates of fertilizer application. So more fertilizer over time has meant more corn over time. So goes the thinking. The hope has been that at the same time, nitrate exports through drainage water coming off of the fields will go down. Uh, that as the corn grows better, it will use more fertilizer, which will leave less fertilizer to leave the fields through water and ultimately get into the Mississippi River and contribute to the Gulf of Mexico dead zone and all of those associated problems. We thought that our agricultural drainage water research and demonstration site in Gilmore City, Iowa, has a valuable perspective on these ideas. Even though it's just one site, we have over 30 years of data now, including several plots that have received a consistent fertilizer rate of 150 to 160 pounds per acre annually. And we thought it would be interesting to compare how our yields have changed over time despite no increase in fertilizer, and then to see how that yield change has impacted nitrate exports. So in the lower left, that's a graph of the yield over time. So yield in bushels per acre on the y-axis and years on the x-axis going from the late 80s to last year, 2020. Our data in these constantly fertilized plots is shown with the black dots. Those are the values of the corn yield for each plot over the years. And then the dashed black line that goes through those is the change in yield over time on average. So you can see that our yields have increased over time despite the consistent fertilizer rate at a rate of roughly 2.2 bushels per acre per year. In red is Iowa's average. So the solid red line that kind of zigzags is the state average for each year of corn yield. And the red dashed line is again that average rate over time. So in the state as a whole, corn yields have gone up by about 2.5 bushels per acre per year over this same time period. So as you can see, yields increase at our site at a pretty similar rate to the increase in the whole state of Iowa without any increase in fertilizer. So it's likely that yields within the state of Iowa would have increased over this time period, even without the increase in fertilizer. Of course, this is one site and your mileage may vary, but overall, we feel fairly confident in supposing that this is more than just a fertilizer story here. On the right side, we have information about the nitrate load over time and its subcomponents of water and nitrogen. Uh, On the x-axis is again the year, that same time period. In the top graph, on the y-axis, there is precipitation in the solid blue line. So that's the water input into these plots through rain mostly. And then below that in the dashed darker blue line, that's the drainage. So that's the water leaving these fields as, as tile drain exports from underground. And so as you can see, the drainage tends to mirror the precipitation pretty well. In the middle graph, that's the nitrate concentration. So the dots are again the values for each of our plots. Those are annual averages. And the solid line through the middle of them is the trend line over time. So there really isn't much of a trend over time. There's a very slight negative trend with almost no correlation. So those have stayed roughly flat. And then the bottom graph is the nitrate load. So that's the total amount of nitrate being exported from this site. So kind of multiplying that drainage line from the top graph by the nitrate concentration, which is nitrate per unit volume in the middle, to get the total amount of nitrate leaving the site. Again, the dots are our plot values, and the solid line is the trend over time, which again, there really isn't a trend over time. There's actually, if anything, a very slight positive trend. Which is to say that as this yield has gone up, as the corn yield has gone up over these decades at our site, we have not seen any real change in nitrate load. So, and that's even without any change in fertilizer, no increase in fertilizer. So it's unlikely that increase in yield, even as that is happening at a state level and beyond, is going to rescue us from our nitrate loading problem. That increase in yield here, even without the increase in fertilizer, has not really had any effect on the nitrate load. I think it's worth pointing out with this site also, and you can see this really in any of these graphs, that if we only had a more limited data span of just a few years, which is often the case in science, we might draw very different conclusions about what's going on here. So for example, if you look at the period from, say, the early 90s, it looks like nitrate concentration and nitrate load are going down. Same thing for roughly 2013 to 2020. But then if you had, say, the later 90s, you might think that those same variables are going up. So this analysis really speaks to the value of having long-term data sets to understand the changes in our crop yields, our water, and our natural resources in general in the state of Iowa and beyond. I'd like to thank the dozens of Iowa State University students and staff who collected this data and maintained this experiment over the years. It's a big effort. I'd also like to thank the Iowa Department of Agriculture and Land Stewardship, Iowa State University, the USDA, and others for funding, as well as the USDA and NOAA for some of this data. Thank you all for listening. And again, if you have any questions, I'll put my contact information in the description to this video and within the Iowa Water Conference virtual presentation. Thank you.